All right, welcome everyone. So I'm going to talk about how we can figure out if AI is used in software development. And so quick word about me, Philippe OMBREDANNE. I was very nicely introduced by Pierre-Yves. I like to think I'm on a mission to make it easier to reuse open source code. And I kind of fell into S-bounds by accident. I happen to be one of the co-founders of SPDX. I'm very much active with the CycloneDX community and standardization effort. And I've created a small standard called package URL or Perl, which is used in all these tools for software composition analysis, cybersecurity, vulnerability database, and S-bounds. And I'm the lead maintainer of a project called AboutCode, which is a suite of many tools for figuring out where the code comes from, using open source data, tools, and standards. Fairly popular. We're about, well, it depends on what you're looking at, but we're with 11 million downloads a month. I consider this fairly popular. In the old days, I used to be a committer on Eclipse, and I had a project which had achieved about 2 million downloads in 2 years. And that was about 20 years ago, and that was a wide success back then. So now you're doing that on a random JavaScript library in a couple of weeks or months nowadays. It's sobering, but still not hundreds of millions, but 11 million a month is a decent number to achieve. So why do we care about using AI in software development? Well, of course, AI is eating the world. And I think it's important to be able to ensure we can do responsible usage of AI features. It's especially important when it comes to code. If all the code is AI generated in the near future, what does it mean for open source, right? Is open source has any meaning? Does licensing have any meaning anymore? There's a lot of things we need to think about. What matters is, as we'll see, and I even do a small demonstration, is that LLMs do memorize the code that's used to train them. And it's fairly easy to make them spit back that code, meaning if your open source project code has been used to train a model, it's possible to have it spit back your code, but of course there's no provenance information, no copyrights, no license, no nothing. And that's a problem for open source projects, a problem for corporations too, because if code from a competitor may have been used to train an LLM by mistake, you may be using code from your competitors. It's probably not something you want. And it's hard to escape, but more and more of the code being generated and more of the content being we effectively risk in general content and in code in particular what I like to think of enchatification, which is a word that was made popular by Cory Doctorow. It's actually a quote from Daniel Thompson-Lifto, will be there tomorrow, just from 2 days ago. If you've noticed, of course, 6 fingers, hands, that's easy, but proliferation of EM dash in contents, tons of emojis, lots of very structured content with a lot of nice bullets. That's a problem. So it's important to understand when and if AI has been used. So AI-generated code search. What's the idea? Is to make sure we can use AI to generate code, but make it in a way that's responsible, and we know what we've been using, so we can enjoy the benefits of it. And there's a massive potential for reuse of the code unknowingly from third party. It's a big copy engine in the end, right? You can use code illegally, but you can easily also inject code that's subject to vulnerabilities and non-vulnerability issues. because the LLMs just know what's the few next tokens and may not know that it's actually vulnerable code. So what we're trying to do is to put together a bunch of tools, not using AI actually, even though that's something we considered, to help identify if code may have been AI generated. So you can then determine whether it's okay for you to reuse that code or not. And eventually help build a better internet. That's a project that's been, as Pierre was saying, it's been sponsored and co-funded by NGI Search. Or, in terms of what we're doing, if you ask ChatGPT to generate a poem explaining what this project is about, that would be another way to look at it. I was actually pretty amazed that I wouldn't be able to write poetry like that, as far as I'm concerned. I'm not a poet. Okay, so let's look back a bit at the problem. It can be, in some case, a wonderful productivity booster. Even though we all know if you've used GenAI for code, that very often the code doesn't compile and it still requires lots of love to get a working solution. In the hands of an expert, it's a productivity booster. Now, if you do a small experiment, imagine you take all the code for the GNU project, which is under the GPL, and you build a small language model. Not a large one, a small one. And you generate code from that model. Whichever way you look at it, the way I cannot think that the code is not derived from GPL license code from the GNU project in this case. Right? Now, if you expand that to a larger bit of code, you still have this problem that exists. And not only AI-generated code may, but actually does violate license and copyright. And as I said, it can also generate vulnerable code vulnerable code sections. It's a bit more far-fetched, but that's still a problem. And we see, it's been a couple of years now, for instance, the Apache Software Foundation has an established policy with regards to using AI in a code that's contributed to Apache. And their policy at high level is fairly simple. It says, you're contributing code as a human. So if you're using tools, you need to disclose that. But you're still on the hook to represent that the code you contribute to an Apache project is effectively yours. And so there's a lot of, the jury is still out on whether generated code can be copyrighted or not. Here, what we see is that if you generate code that's strikingly similar to open source code that was used for the training, then whichever way you look at it, I can imagine a judge seeing two pieces of code, one generated, one original, and they're the same. It doesn't care whether the thing was generated or not. That's really relevant. It enters the realm of copyright. And I think that's something that we need to be aware of. So let's do a small demo now. What we did is to build a small data set of about 260,000 open source software packages, including the 50,000 most popular NPM JavaScript packages. And most popular being, it's a difficult thing to determine how popular is an open source package. Here it's based on the number of dependents, so number of other package or apps that depends on these packages. So that's a small data set of about 20 million files that we did index. And then we asked ChatGPT using GPT-4.1 to generate code similar to the top most popular 100 most popular JavaScript packages. We save the generated code file and then pass that through our scanning engine, which is doing a bunch of steps. And what we see, and let's go through that now. So we're going to start from the bottom. on the left-hand side, yes, left-hand side. On the left-hand side, you have a simple prompt in ChatGPT where I'm just asking, hey, generate code similar to the code identified by this package URL. I'm a bit biased by package URL because that's a standard I created, so I like to use it. Asking just to report code, and you can see similar code on the right, which is the original code. It's not a huge bit of code that's copied, so let's look actually at the tool itself. In this case, we run in ScanCode.io, which is the front-end tool we have in the stack where you will do this AI code detection. And generally speaking, copy-pasting code detection. We'll see that we have this section of code that was identified as being derived from the original package, which is this package from Isaac's here, version 203. And we have a few metadata, information about the license. So that's the essence of what the tool does. Now, if we look at something a bit more meaty, as I said, looking at the top 100 most popular NPMs against the top 50,000 most popular NPMs, we get about 30 packages detected out of 100 requests for generation. It's actually, if you look into the details, not that bad. It's more in the range of 20%. So 20% of the case of code generation will have strikingly similar code snippets derived clearly from the upstream open source package. This is not science. This is anecdotal. I don't claim to be a scientist. I'm just a practitioner. There's real scientists that have made research in that space, and they estimate for code that it's in the range of 2 to 5%. So my 20% is probably super biased. But it's practical, and it's something that you see as a real issue. Now, at a high level, how does this work? When in ScanCode you create a new project, you have a bunch of pipelines, and you basically can ask code matching against the index. That's the gist of it. It's a UI, there's a command line and an API, and you can just, it's a bunch of containers, so you can install it locally, and you're welcome to try it out, and you know where to hit if you have a bug. Okay, let's go back to the presentation. In terms of how we came to this solution, the first idea was to say, well, you know, let's use GenAI to fight GenAI code generation. And the idea was to say, for the code we need to analyze, feed that as a prompt, and stopping on a regular basis asking for completion. And then using the code that's generated, finding afterwards if it would be generated in a similar way to code that we were trying to consider as analyzed. We did a few experiments. It works. It works actually very nicely, but it takes an arm and a leg in terms of cost and takes forever to complete. So it's conceptually working, practically unusable. Our approach is to say, no, we're going to find similar code fragments. If the thing that I care for is that if GenAI generates code that may be similar or strikingly similar to existing code that has been used to index that, if it doesn't, you know, what can we do? It's no longer a copyright issue, and it may be a security problem, but it's not a security problem that we control because we won't be able to find known security issues, CVs that may have been registered. The other thing we were considering is to use a traditional search engine. Google, for instance, has a limit of 32 words for a query. It's difficult to make very large queries. Here, the query is potentially gigabytes of code, which is your code base that you're running analysis on. We need a way to reduce the dimension of the problem. That's where we use an approach based on fingerprints. And there's an alternative using a bitmap index that we're considering as an optimization in the future. But so the approach is to say we're breaking code into content-defined fragments. For each of these fragments, we compute a fuzzy fingerprint. Technically, it's called LSH, locality sensitive hashing, which is a small bit string. And then we match that in similarity to see how similar it is to existing pre-indexed code that we have that's been fingerprinted the same approach. To picture what these fingerprints are, think of it about these two cats. They have different tail, overall similar shape, different eyes colors. If you reduce it to a very tiny space, let's say 32 by 32 pixels, you can match that to any of the two cats because the color has been abstracted, the shape of the tail has been abstracted. They're actually exactly the same set of 32 by 32 bits. It's conceptually similar to what we're doing in using these dimension reduction algorithm for these fingerprints of code. And so the results, again, 20 to 30 times out of 100. And as we're running more tests, we see that code is memorized when used as an input for training of LLMs. And code, everything actually, all the content that is used is eventually memorized. And I think it's going to be growing more and more as the size of these LLMs, the number of parameters they're able to deal with, the speed at which they're able to return information grows. We'll see more and more of these memorization capabilities. I like to think of an LLM as a lossy compression engine. And it starts to be less and less lossy. We've integrated that in the rest of the tools we have, open source tools in AboutCode, so that makes it for a well-rounded experience that is able to detect a lot of other things in the supply chain. And still lots of work to be done on our side to improve the experience, be able to see side-by-side results. We have the data internally, but not the UI yet. And always, scale up right now. We're dealing with a couple million packages, but what if you have 100 million? And scaling is hard. And I don't have the CERN budget for that. I wish. So some other initiatives also. We're blessed to have been also supported by the NGI program for other projects. One of them is called CraveX. And the goal of CraveX is to provide a tool suite to enable CRA compliance. So what we're doing is having a bunch of tools to figure out where the code comes from, what the license, are there non-security issues. Here we're trying to help with the compliance last mile, meaning you have a bunch of products, you need to figure out what they're made of. And are there non-security issues so you can communicate with your users, your customers, hey, there's this CV, it doesn't apply to me. Or there's this CV, you need to upgrade to this version to comply. And here is RSBOM, so eventually make it easy for small and medium companies, and potentially larger too, to comply with the core obligations of the CRA. Another one is to scan software heritage. So if you don't know software heritage, it's an archive of most of all the open source code out there as source. And we're working with them, also with support of NGI, to ensure we can scan for license and package metadata, 30 billion files. Something I wouldn't be able to do it alone because I don't have the CERN budget for unlimited storage. But software heritage has access to some of that, of course. And last, some future initiatives. One is to track if GenAI is used in a software product. So it's not about GenAI code generation here, is which models, which license of which model, which provenance of this fine-tuning, which API am I using in a given code. That's a problem a lot of responsible lawyers have in any company that creates code. And also, last, collaborating with Hugging Face to create a new version of what they call the stack, which is a data set of open source code used to train LLMs and done in a responsible way. We scan code so we can know the provenance and license of each of bits of code that went into training these LLMs. So eventually helping the other side of detecting if code has been generated with AI.